first like to start by thanking you, CC, George, and the organization. And I just don't want to be polite. I'm very, very sincere. At the beginning of the year in our team, we decided of the strategic arenas that we would, focus on during the year. And indoor location services is one of them. So when you invited me for this conference, it was right on the topic of interest to our team. And I think that's, I know it's the first occurrence of that conference. I think it's with an initiative like that, that we can get together people interested in the same topic and really make a difference. Make our knowledge, our common knowledge go faster. So I really thank you for this, and long life to your conference. So as CC mentioned, I work for Bentley System. In Bentley System, we develop software for the architects and engineers of this world who want to create the infrastructure of this world. And within Bentley, we have a team that is called Strategic Technologies. It's the team I lead. We have, I have the chance to have 30 developers in that team. And our focus is to, as soon as there are new technologies, new market trends, something that can improve the life of our user, then our team has to learn those new devices, those new technologies, and try to explore them as quickly as possible so that we can innovate as quickly as possible. So I will admit that I think I have the best job at Bentley. By the way, I also thank you for inviting me here because it's my first time in South Africa. I think the people have been extremely welcoming, and it's a 45 degrees difference between home this morning and here today. So I appreciate it. So let's start. So I will talk again about location services in the world we work within, which is about designing, building, and operating the infrastructure of this world. The way I want to do that is I'll let build a couple of slides about Bentley. But when I was asked to present, I said, well, I guess that the best way to get the discussion going with you experts in this domain would be to present the use cases that our users have and how location services could help them being faster and more cost effective and so on. So the most part of my presentation will be about the use cases in this life cycle. And then from that, I try to summarize the requirement that these location services should have in order to satisfy our discipline. And I'll have a few ideas about looking forward. So with Bentley, I already mentioned it. So we develop software for architects, engineers, surveyors, mapper of this world who create all the infrastructure that surrounds us. So it's about everything that you see on this slide. It's about roads, telecommunication, building, campus like airports, university, stadiums, manufacture, lots of offshore wind platform and offshore wind turbine is really very popular these days. And you see those software that we have, and we have more than 100 software that cover all this range. Maybe you've heard of MicroStation and ProjectWise, which are the two most popular that we have. But we have a wide range of software that cover all that. And now we also have apps that work on the tree platform, iPad, Android, and Windows. So we try to, be in sync with what the technology is offering us. So that's what Bentley is doing. And so I'll be talking about use cases, but in a short presentation, I cannot cover everything. If you want to dig more and see more about what our users do, every year we do a contest among our users who submit their realization, and it's like the Oscar, you know, we have a big party and we give the prizes to the best one, and from that we produce a catalog. So they are catalog produced every year. You can access them digital, or you can order a paper copy if you want. And every year we are amazed to see what the user can do in today's world. Like I have a couple of examples here. You know, they can do buildings that are totally, you know, innovative, or bridges that are, you know, extremely interesting in terms of dynamic physics and so on. So these are very inspiring work that they do. So you're welcome to go back there and see what, you know, location services can do in this case. So let me start. Infrastructure life cycle. So when you build infrastructure, you go through different phases, different steps. And these steps will vary according to the organization and their priorities and their context. For example, at our conference a month ago, Siemens was presenting, and they were insisting on the years that each step take during the life of an infrastructure. And here I want to bring your attention. So they said design, build, operation, and dismantling. What's interesting here, we were talking about 50 years of operation on average. I mean, these are statistics, of course. And that represents 60% of the operation cost. Meaning that it's a very important step in which I think location services can make a difference. And I will have examples about that as well. Another organization, Fiatec, who focus on innovation in their world, in the world of building, constructing, and so on. And you see that the step varies a little bit. They have planning, they have procurement and supply network. So that varies. And at Bentley, we've been for years talking about plan, design, build, and operate, which is, you know, in the areas in which our software are involved more. And for this presentation, I decided to merge plan and design together to present the use cases, just because in many cases, projects are, you know, have to be accomplished faster and faster with more, with schedules that are shorter. So it's often the case that they start planning and they start designing at the same time, and we do that together. So to simplify on my presentation, I decided to focus on design, build, and operate. But remember that there are other use cases. If you go in details, there are other phases, and there can be other use cases. So let's start with the design phase. There are different projects that are about creating a totally new infrastructure. Other projects are about transforming or renovating existing infrastructure. And there are other projects that combine both. But in all cases, they need, to some extent, to capture the reality, because they have to connect with the physically existing world. Of course, when you renovate and transform, it's more likely that you will have indoor cases. But there are some other external that I want to talk about. Here I have a project, a very amazing project that has been happening for a few years now in Europe, in the London area, which is about creating a 100-kilometer long new train route that goes outside and in tunnels. There are 42 kilometers of tunnels that are planned. To serve that route, 38 stations are required. That's the biggest civil project in Europe as we speak today. So now imagine, of the 38 stations, there are 9 that are new, but 27 that were already there. That's a lot of indoor situation where you have to capture the reality, because you will have to connect and transform and measure and do all that in those 27 stations. Plus all the tunnels. The tunnels are underground, and they should not conflict with everything that is already in the city underground. So lots and lots, thousands of hours have been spent in capturing reality in this case. So any difference that we can make to to diminish the time that it takes to capture reality and maybe to add precision is really, really welcomed by a project in an organization like this. Here, just to give something concrete as an example, they have been extensively using point cloud as one of the photos and other ways also, but point cloud was one of their main choice. And here I have a little video showing in one station, the Paddington station. So you see the tripods, so they've been capturing, putting the tripod, the professional equipment at different locations. And then of course, the problem after that is all those scans, you have to register them. You have to do relative orientation and absolute orientation in order to get something as fluid and a 3D model, a single 3D model of all the station. Now imagine all the work required. For each of the tripod position, you have to install targets, survey those targets, you have to register those, have to recognize those in your point cloud, and process with adjustment. That's a lot of work. Now imagine if for each of those devices, you could access a very precise location service that would give the exact position. How much time they would take? That would be a starting point for all the bundle adjustment that could save lots of hours. Of course, this is a type of indoor location service that would require lots of precision. But even if it's not that precise, in the first, we have to be, how can I say, we have to be reasonable. And that's not in 2014 that we might have very precise location services. But even if it's imprecise, that could be a starting point that helps saving time. In the future, I imagine that you could even walk in a station like this and just walk around with a laser scanner, and at the speed that you walk, it could scan everything and be registered automatically. That would be awesome, and that's where we should be targeting. I know that there are lots of professional equipment vendors like Trimble, ZNF, Regal, and that are doing a lot of research in this area. How can we move with equipment and do that faster? But what I found interesting recently, not if you're aware of those scanners that just went on the market, and some others will come in the market in 2014. These are much lower cost. These are, between professional and consumer world. And it shows, it's just like when the smartphone appeared, it was not only professional, but it became consumer, and then everybody is using them. So I think that the same thing might appear, and then there will be more and more devices. Those have the particularity that you can take them and move with them. And as you move, the relative orientation is done automatically. That's the case of the first one, structure sensor, that is not yet released, but by reading the documentation, that's what we expect. You plug that on your iPad, and then you move around. The second one I've been able to try it personally. It's using a tablet, an Android tablet with a scanner, and then as you move with it, the feedback shows your points in green when they are registered, and in red when they are not yet registered. So you have just to slow down, then they turn green, and then you can scan, and after that you have a relative point cloud that is relatively oriented. The last one is have you seen the last one, ZBD? It looked like a toy when you see it working. You take this handle, and the scanner, which is on the spring, goes like this when you walk. And it scans at warp speed. And the precision is not that bad. So for areas where you have to scan very large areas, fast, maybe repeatedly, maybe every day, then if the precision, well, that's the precision that we offer today, but you can expect that it will improve in the future. So that's another example of thing that is appealing. So I think that it evolves very rapidly, and we have to use them. However, knowledge, none of those, have automatic indoor positioning. Some of them have, GPS, but when you're outside, but for inside, no one has. So that's another difference that we can make there. Another use case is about reviewing the existing information on site. Now let's imagine if I take the train station. The train station has been there for many years. There have been projects, the first project was about creating it, but there was renovation over the years, maybe 5 years after, 10 years after. So you accumulate lots of documentation about each project. Remember that each project could have thousands of documents that are plans and designs and material lists and schedule and all that. And it's archived somewhere. But one of the problems that our users are facing is if you don't know the project number, if you don't know who did it, when it did it, especially newcomer or subcontractor, they don't know everything that exists, and it's difficult to find. So one of the things that we've been working on is, let's say that all those documents or projects are geo-referenced. Now if you go in the field, by your location, you can query spatially all that documentation and get immediately all the documents that correspond to what you do. So here I have an example of a little app that we released. And it will show you with GPS, which is available today, what it looks like. So here are the little data that I need to access. So this is an app that works on the iPad. It's called Field Supervisor. And here you see by your GPS location, it shows you where the projects have taken place in your area. And by knowing, so if there were 5, 6 projects in history that were in the same area, then you could see them. And then by selecting the one or these projects, you can then have access to all the information, all the documents, all the plans that are related to this. So this app works today with GPS location, but for indoor, that would be awesome if we would have a location service indoor to do the same. Another thing that people want to do is, when they design something new, they have to share this with stakeholders and have them approve, have them view it. And there's, if you come with paper or some 3D plan but on the screen, it's not like being on site with the reality. There's nothing like being on site to really appreciate. So that's where we can talk about augmented reality and the potential that it can give. Of course, when you talk about augmented reality, you need to take the reality, maybe seen through the camera of your tablet, and register that with your 3D model. Now, to be able to register that properly and automatically, it's a big challenge, because you have to know the exact position of your device, the orientation of your device, where you look, the compass, and everything. And when you move, you have to readjust automatically. So it's a huge challenge. But we have some cases where we can make it work outside. And I have an example here with this little demo, a very small demo. Here's it's a passage between 2 buildings. And here you can see, in this case, we have viewed street views because those are fixed, so it's easier to register. But you can imagine that you could do that automatically eventually, and inside as well. So augmented reality inside would require a location service that is very precise and very fast to be able to do the registration. So these were examples in the design phase. Now let's go in the build phase. We start constructing. A construction site is, of course, there are so many things moving around in a construction site, especially a big project that could be hundreds of workers, lots of tools and material. And then we can imagine if we talk about the crew, each of the workers have a specific task to do. They have to go to a specific place, take the appropriate material, take the appropriate tools, and then do their work. If we add location services, indoor especially, we could help those people go faster to their appropriate place and have access to the material or tools that they need. So where am I going is the idea. You help the person go immediately and you don't lose time and make potentially errors. From a management point of view, the project manager wants to know where everybody is during the course of the project. So if he's looking for a specific person, if he's looking for a specialist because they have an urgency somewhere and they need a specialist to do something, then by having, if everyone has a position, he could find them faster and don't lose time. Same for tools. A few weeks back I was at an EP6, a big firm that does engineering, procurement, and construction. And one of their problems was with small tool management. They were saying, we have very specialized tools in a limited number sometimes. And then a worker goes with one, he do his task, and then he's done with his task, but the tool stays there, many hours. And maybe some people, some others need it, but then you have to find them and you lose time. So that's a problem. And I was seeing this ad from Ford recently that is similar, which is, I don't know if you've seen that, so that you can have your truck equipped with a system where you put RFIDs on each of your tools, you go working, and when you come back, you put the tools, in your truck, and then you push a button, and the button, then it will tell you if you have all your tools or if you forgot one and which one you have forgot. So that's really good. Another example is about material management. This is a building in London, the Park House, where each of the glass panels that you have there, and there are thousands of them, each one is unique. There's not a single one that is repeated. So it's an architect dream, but an engineer and constructor problem. And you see more and more of those buildings because we now create software that allow architects to do whatever they want, generative component, innovations. But that becomes a problem. So if you could put RFIDs or some type of device on each of the panels and have scanners that allow you to know every time where they are, so when you need one, you know exactly, you can navigate the person to the proper material and bring in. So that's another case where the location service would be appreciated. Here the conference is about indoor location services. I think outdoor, we already have solutions, GPS or GNSS, work quite well, and people are already using them. Yesterday it was mentioned that it's important that we have a seamless indoor and outdoor experience, and that's also part of my concern, because here are a few examples of cases where it's a mix of both. When we start constructing, we're obviously outdoor. But as we put a roof and as we put, installation, then it becomes partially indoor and then totally indoor. So, a refinery, of course it's outdoor. But look at the complexity. And there's no GPS signals that will be good everywhere, necessarily in those cases. Campus is another example. You have part of the campus that are inside, other parts that are outside. People that are doing maintenance or construction, they need to go from to the other. And tunnels, trains. Parts are in tunnels, underground, other parts are outside. So there's always, this mix of both. And I insist that I think we need, from a software development point of view, we don't want to have to write a software that will work one way for outdoor and work in 5 different ways indoor, because there are 5 different technologies that are being used. We'd like to have, ideally a single service that allows us to seamlessly work in both places. When you route crew, tools, and material, most of the systems that you know today, if you use GPS, for example, they only consider that the moving object is a point. And that's, pretty easy. In our case, we have material to move, and there are constraints that we have to satisfy. Here, this example of an application that we offer today is called Superload. It is for outdoor, obviously, but every time that huge material have to be delivered on roads in the US, they have to get a permit, and with the permit, a specific route is given. And then when we calculate the route, we consider the volume of the object, the clearance of the bridges, the width of the roads that they have to go through, the slope and everything. It has to be considered for the routing, and it makes the routing way more complicated. For indoor, that's going to be the same thing. If you have to bring in material that is huge, you have to consider the volume in your routing algorithm. Retrofit is an example. You have something that is already installed, like a big tank in a refinery, for example, and then you need to take it out and move another new one. So how can it be moved without clashing with the rest of the thing? During construction, schedule is very important, because if they don't deliver on time, they will have penalties, huge penalties. So every day they have to monitor the progress of the construction. How they do that? Well, today they go on site and they check, what is supposed to be done today. It will be on a 2D or 2D plan or a list, and then they go everywhere. We've done experiment where we could do that with augmented reality, comparing the model as it should be today with the reality. You merge both, and then everything becomes more obvious. In situ design is, let's say that you have an assembly to be done on site, and it could be pretty complex, so you have to take measurement. You have to know where exactly the window should be cut and open and so on. So we've done experiment, again, using augmented reality. And this is example, you see, in this case, he's using glasses with a camera that merge the reality and the model. And here the model is about building. It's a very simple example, but just you get the idea. It gives, the plan of where exactly it should fit. In this case, the orientation sensor that we were using was very bad. That's why it's moving. If it's a complex assembly, then you could have a simulation that shows how things should be assembled and installed on site. And then it gives you measurement of how it should be placed. And eventually, it could assist the person to create an object and tell him where to place that object exactly. So this is for future, I agree. But at least you see the fact that if we have good indoor rotation service, we could make this a reality. This is a very interesting example. You know that during the course of construction, people face surprises. The engineer designed it in some way, but they have surprises. No, it doesn't work. It clashes with something else, or all kinds of problems. They have to take immediate decision and change what they were supposed to do to accommodate the surprise. But rarely the design is updated with all those corrections. So when you finish the project and all the walls are closed, nobody knows exactly where the things are. So the as-built, as we call them, are not up to date. So it's a big challenge for us to find ways of having as-built that really represent what has been constructed. This idea here is about using point cloud. The idea is every day maybe, on the construction site, you go and take point cloud. And then every time that something else is constructed, and as it evolves, you take other point clouds. And we've been looking at, if we are able to difference point cloud, how could we highlight the exact status of the project in history. So this little app experiment shows a slider here that allow you to go back in time and see the progress of the construction and where things are with the precision of the point cloud. So if I start it. So this has been simulated, of course, but here, as I go back in time, I can see what's behind the wall. And if you have done that, let's say you have taken hundreds of scans daily, then you can, once those are registered, you have a 3D model with all the history, all the temporal aspect. And because you have this 3D model, then you can navigate in the model and go back in time, go in every row and see what's there. Of course, scanning every day represents a challenge because today with the equipment that we have it, but it would probably be too costly and to take too much time. But if we have location services that could help making the things faster, and the volume of data that we accumulate is also an issue. Safety is another aspect. Again, with one of the user I was with a few weeks back, he said that people being struck by moving object is the main reason for fatalities in the projects, the construction project that we have. So again, if you have ways of knowing where people are, where moving objects are, you can limit that. There are some solutions that are coming on the market for that as we speak. Or if people go in unsafe area, you could warn them, check if they have the appropriate equipment, assuming that these equipment would have RFIDs or something, then warn them, okay, you cannot come here, you not have your app, or you don't have this thing. If there's an emergency situation, you want to egress the people at the appropriate place. I was visiting mining user last week in Johannesburg, and they were saying that underground, if they have indoor location service, safety is extremely important for them. And where an accident occurs, let's say that the tunnel is closed for some reason, it's a very complex network underground, and then you would like to guide the people to the appropriate place as quickly as possible. And that's another case. The third phase for which I have use cases is once the building the infrastructure is built and you start maintaining it. So remember, that's the phase that is longer and is more costly. I was saying 60% of the costs are in this phase. There's a study from an institute in the US, the NIST, that we're mentioning that 15% of each day is lost in tracking information that is required by the maintenance people. And this diagram basically shows that if you don't have proper maintenance, then the performance of your assets diminish and the life of your asset, your facility also diminish. So what can we do in this case? So we thought that, I mean, if people need to have access to the appropriate information, then we thought about an app that could be on a tablet that could list to the person, here are all the maintenance tasks that you have to do today. And then for each of them, help them navigate to the appropriate place without errors. And remember, people doing maintenance are not necessarily personnel of the organization. It could be subcontractors, it could be people that are not used to this facility. So they have, providing a tool like that would help them go faster and don't make mistakes. And then when you are on site, where you have to do your maintenance tasks, have access to all the information about the valve or the pump or the tank or everything that you have to do. So we did some little prototype. The first problem that we face is, if you want to navigate someone indoor, outside we're used to have a map and some 3D map as some feedback. Inside, ideally, you would like to have something like that, like a 3D model that shows you exactly, what's around you. But you can imagine that most organizations, they barely have up-to-date 2D data, and many of them don't have 3D data. So how can we make that very cost-effective for them to provide something on the tablet that will help them navigate? So here's the experiment that we've made. First, the things that you have to maintain in the facility, that's not everything that is in the facility. That's only a small subset of what you have there. So why only investing in creating a 3D model of the things that you have to maintain? Because those are required because you want to associate those things, with the semantic information so that you can access a server and have access to all the appropriate documents. But to give the rest of the context, where are the doors, where are the windows, where are the stairs and everything, why not taking just photos? Those panoramas are easy to take today, it's cost effective, and then you merge the two together and your survey is done and you have a 3D model that allows you to navigate. And then after, for the many years to come, when you do maintenance, you provide a tablet with the ability to access the jobs to be done today, and then some feedback. So here a little demo of it. So this experiment was all done on an Android tablet. First, we model only the object that have to be maintained. Oh. Speed is not very good. Here you have a top view of the object that has been created. These are vector objects. And then to get the panorama, we use, in this case, Photosphere, which is an app that comes with Android. You have the same, similar on iPhone, and you have some others. And we took those photos, and with if you imagine that you had a location service, these photos would be immediately placed on the right place so that the 3D model could be registered faster. Here on the tablet, we were showing, very with touch command, how you can register the 3D model and the photo together so that you have a model to do the navigation. When you start to do maintenance, now imagine that you have a location service. Well, first of all, you can check the task that you have to do for the day. Don't look at the user interface, it's pretty rough, but it shows the idea. And then for the inspection or maintenance that you have to do, you can see exactly what you have to do. And here it's a very poor-man's simulation of a location service that could help you navigate to that place. And once you get there, by your location or by selecting the object, you would have access to all the information, properties of the object, the document that describes how to do the inspection, If you need parts, maybe check your inventory to see if you have the parts available and so on. Another example during operation, so you have to do maintenance. Here the idea is, what if I could see behind the walls? So this experiment is about using a tablet and a camera and clipping your image and showing the 3D model within that clipping portion, so that you can see the pipe, the electricity, and everything that is behind the wall. So in a maintenance or in an emergency situation, you could know exactly where to open the wall. And there are many other examples during operation that can be done, like inspection. During inspection, you see something that needs attention, you take pictures, you take a video, you want those pictures to be located so that the person that helped you can immediately see at the right place. Tracking tools and material, safety, which I explained during the build phase, are also necessary during the operation phase. So these were the use cases. Now from all that, what are our requirements in terms of location service? First, it's about accuracy and coverage. What I mean by this is, you've seen an example where imprecise location service would be satisfying, like to navigate someone to a place. But we have other cases where very precise location service would be required. Now, in terms of the software, we need to be able, when we query maybe a web service that gives us the location, we need to be able to know what is the accuracy of what is provided. Because you can imagine that the facility will be equipped with different type of devices, maybe Wi-Fi, maybe iBeacons, maybe reverse RFIDs, and so on. And then as you go around, you will want the system to be able to tell you how accurate and what is the coverage of the Wi-Fi. So this is something that would be more. I talked about when doing routing services, to be able to consider the volume of the object and be able to do clash detection. Seamless outdoor indoor. And of course, the use of standards as much as possible. From a software developer point of view, writing the same thing 6 times because you use 6 different hardware doesn't make sense to us. We prefer to use a standard and write it once and it works with all these devices. Looking forward, so hopefully I convinced you of the potential of good location-based services for indoor in the disciplines that we cover. Also, there's one thing, we all have dreams. I'm sure you have many dreams about things that you would like to do. As a software developer, there's one thing that I think would be very promising. And it's, our software is about designing new infrastructure. If we know that we will use indoor location services, that will require some hardware to be installed in those facilities. So we imagine when everything will be available, we will work to design and immediately design it with the appropriate hardware at the right place, right? So this is, and do that in an optimized way. So here's an example of what I mean. Let's say that this is a cement factory with indoor and outdoor. So let's say that this is what I designed, and then I identify all the tasks that I will have to perform that will use location services. For example, there could be tasks that require precise accuracy, maybe using slab or using techniques that could be more precise. Other areas will require medium accuracy, and others will require low accuracy. Once you have done that, the software could help you identify, okay, for precise accuracy, I need that type of, I select that type of technology, and it will place the hardware, the devices at the right place, making sure that the coverage is good, and so on. And then you do the same for medium accuracy and other technology, and maybe Wi-Fi for low accuracy. And then you get a system that covers all your location services. And then the software could offer simulation. You have conflict with the coverage. Now there are places that are not covered. How do you could simulate routing. You could test with different material because the type of material you select for your walls and everything have an influence on the propagation of the network and all that. So you could test that. You could simulate, maintenance tasks, measurement, and egress. So that's food for thought. And if you are interested in this topic, I welcome you to come to me and share about it. So in conclusion, I've shown you many examples of innovation that we've been working on augmented reality and some other. We now have a site at Bentley that shows the result of these innovations. So I welcome you to go to bentley.com/innovation. And every time we finish a project, we expose it on this site. There are already maybe 50 of those innovations that are explained on this site. So here's what it looks like. If you click on one, you will get more details. Often there is a video and at least some images and a description. On what's very important, we want collaboration. So if you want to discuss this project, bring your idea, give your comment, it will link you to our B communities where you can interact with us and share your ideas. And of course, we have the rest of the week together, and you have my email, so you're welcome to email me every time about ideas and collaboration ideas that you have, and I will welcome. So thank you. We received our Google Glass, first Google Glass at the office yesterday. I received an email. So thank you. As you would see it if you have